Okay, so I want to record a debug session for one of the issues that somebody has reported to us in XState. And the issue is about our inspector being broken in a way. And the reporter has prepared a repro case for me. That's very sweet. I have this repository open here. And the issue manifests itself if we open the inspector. I have just refreshed the application itself just to have the whole thing like restarted because this inspect call opens a new window within it with the inspector. So we have this inspector here, this very nice feature, very helpful for debugging and inspecting your application state. But yeah, let's get to the point. We have this graph, this diagram, and the user has noticed that if he clicks on the open event, then the machine transitions to this temporary state with the invocation here to the loading state. Then it just goes back to idle and kind of gets stuck in the open state. Why we even can say that it gets stuck here? Because in the application itself we are actually logging the current state, and we can inspect that the current state right now is idle closed. So why this thing is not highlighted like it should be? So let's start looking into this. One thing that we might want to do is to refresh it again. We might open this window here, and we can notice that actually when I click on the open event and it just transitions back, it froze. So we can see already the error here. So like something crashes in the application. That's a little bit of a given. Cannot read properties of undefined reading data. Okay, not very helpful, but what we can do is click in here. We like this deployed application. It's not it's not running on our local development. I could probably spin it on the local host because I have access to this code base and all, but that's a little bit of a chore for me. So I can actually click here and pretty print it. So I can almost like read it. It's minified, so you know some variables are obscured here, but at the end of the day, it's pretty readable to some extent, obviously. I'm somewhat familiar with this code base, so I already can recognize that this is actually a state class, and it throws on reading even the data. Okay, that's a good piece of information. Why does it froze? Well, we are already past that point in a moment, in a way, like this error has already happened. So maybe let's restart the whole thing. So we just reopen the application, the inspector, and now we have this very useful thing here. We can click this to make the debugger pause on all exceptions. Like we can also tick this checkbox to actually pause on everything, even on code exceptions. This is sometimes very tedious because a lot of like the initialization code, especially in like some polyfill libraries, is throwing stuff. So if we would have to like refresh the application and try to catch some error that happens down the road, with this checkbox being ticked off, well, we would be stopped quite a bit and it wouldn't be as helpful. But the whole initialization has already been done here, so I don't care. Like I could tick it off, or I can tick it on, whatever. One thing that I prefer about having this enabled is that actually I'm not sure if there might be some error handler like a catch clause somewhere, like higher up in the stack. It might be in React, it might be just in some custom code. And I really want to get stopped, like where this particular error happens. So it's better for me to take it on and maybe step through some additional layers. But I don't expect that to happen right now. So yeah, I always start with that, and I can only like disable that if I really feel like it. So now we can click this, wait for a second, because like it's processing, and hey, we are stopped here. So let's see what happens. Yeah, like this event is undefined, so it's not surprising that this froze. But like, why is it? We can just inspect arguments that has been provided here. So this argument is actually a string, and this should be an object. And we can even see here like unable to serialize circular reference is too complex to analyze. This is pretty interesting because like how this has happened. Like we are sending whole objects, those state objects or something that represents them, through post message, because like those two windows are communicating through post message to do its magic, because like this is a separate window that displays this inspector thing that is synced to the application itself. So yeah, maybe I will even like zoom the code a little bit to make it more readable. And the very important thing for me when debugging stuff like this is to look on the call stack. It's like a basic thing for me. So we can just try to like link it to the root of the problem. So let's jump just to the very first frame here, and this is I'm not actually yet sure like what it is, but we can sort of see here that that this might be a function, because like this happens in the O function that is being used here as a message handler on the window. So it just like tries to sanitize the input argument, this E. I can log it here and inspect it like for my convenience. And yeah, like data on the message event is the data that we have sent from the other side of the application. We can see that session ID is set, type is set of this event correctly, but state is this weird serialized or rather a broken thing, this string. So the obvious conclusion for me here is that the problem is actually not in this application, but in the not in the inspector application, but in the application itself. So I just need to track it down there, because we really should receive something usable as state here. So the problem is in whatever code that sends this event. Some asynchronous stuff can sometimes be seen in the stack trace, but unfortunately in here we don't see any additional stack frames, async stack frames here. So I need to manually, in a way, track it in the other application. And the point is I can see that this event is actually has some distinct type. It has service.state type, so I can just copy paste it, go to the other application. In here I can already close the debugger. It's not as useful for me right now, but I can refresh the application to just restart it. Go to sources and search here to search for in the hamburger menu or meatballs. I have found search. That's also can be found with meta key, shift and F combination, but I don't know, like I'm just using that manually, and I can search through the whole through all the source files here. I tend to like this was a string, so I could wrap it in a string in quotes, but the problem with quotes is that we have two kinds of quotes, like we have double quotes, single quotes, and I'm not sure like how it is actually written in the transpiled code, like which quotes are preferred. So I just start with service.state, and we can even check some potentially unrelated stuff here, but like we have all occurrences of this string. So let's just click here, and yeah, we are already pretty close. This code is actually not minified because it is running on our local host, but it is still transpiled for Webpack, so it might look a little bit weird, but I don't know, like I'm somewhat accustomed to that, and I even prefer reading such code. It still looks very much for me as the original one, but it doesn't have any lies. Like, you know, you can have subtle differences between your source code that is actually seen by the browser itself, the source that has been shipped to it, and your source code from the IDE. Like, it goes through multiple steps of transformation. It might go through like some TypeScript transpiler, maybe Babel, maybe it gets minified, it gets concatenated by Webpack and all of that. So there are certain things that are happening here, and it's better for me to focus on what the browser actually sees. And we can here already somewhat recognize that this area of the code is sending stuff to the other window. So we were interested in this service state event. We can try it here. Search in this file by clicking Command plus F, and we are sort of already here. So maybe let's just add a breakpoint here and get to get us stopped here when the problem happens. So now we just need to repro the case itself. So let's click on it, get back to our application, and we can inspect the whole thing here. I'm not yet sure if this is if this one is the correct thing that will be if this is the broken thing that will be sent to the other side. Like, this is some one of the hits on this line. So I don't have full this. We could get to this thing multiple times in response to my click. So I'm not sure if this is actually the faulty one, but I can just grab this whole object, copy it from the argument, and paste it here. So and actually we can see that this is not the faulty one. This has been serialized just correctly. So I don't expect this to be called too many times. So I just continue. We are being stopped here again. Basically the same code is being evaluated here, so I can just paste it again. And hey, this one will result in this broken state. So let's inspect the state itself. It looks okay. So we are in this the argument looks okay. So there has to be something about its value, like some object in it might be breaking it. So let's just step into this whole serialization logic. So yeah, I need to step through some Webpack stuff multiple times. And we can see this selectively stringify call on the state with those properties and custom replacer, but we didn't actually configure the replacer anyhow, so it's undefined. Yeah, so the problem, like, this is still not broken, so the problem has to be in the selectively stringify thing. Let's just step through. In here, we kinda can recognize some kind of a loop. We have a classic loop here, just using the iterator protocol, and it copies some things from the value, so from the state to the selected empty object that is being created here. So I can try to like continue to here from the context menu. I have found this to be a little bit flaky at times. So like this is very useful, continue to here, because like I don't have to set up a breakpoint here, click continue, and then disable it. It's a temporary breakpoint for me. I don't want it to be here. I don't want it to be preserved here. But I am actually going through this process of setting a breakpoint, continuing, and disabling it quite a bit, because I have found that continue to here doesn't always work correctly. I'm not sure like why, because it should just work, but that's my experience. I would really wish if this could work all of the times. You might want to try it because it's very useful. I just have a varied experience with it. So we are calling JSON parse on the result of the stringify call here, and the stringify receives selected and replacer. So let's just again step into that just a couple of times. So we get through the Webpack stuff. And we have like plain JSON stringify call here. So, okay, let's step again. Oh, okay, so we actually have been put in the catch block here because this JSON stringify has already thrown an error. So we can just inspect it here. I can see that it is being referenced as E. So I just log it here, and we can see like blocked a frame with origin localhost 3000 from accessing a cross origin frame. Okay, so that's definitely part of the problem, and we can even like go back to the application and find a faulty place somewhere here. Yeah, and we have this resolve call annotated even by the user, that when we remove that, the problem disappears. So like it was a little bit obvious that something is off here, but I was able to that something is broken with this particular object. But I was able to like showcase how I can track it even without this information, and also like how, like even with this information, I still need to track it. I could maybe set up a debugger here or in the browser console or other browser DevTools, and just step through here. But a reversed approach is like from the error up the stack is often much more has more information for me in a way. I prefer that. I don't know, like when I was initially debugging that, I gone through like both paths in a way and just confronted them. But right now we already know that something is wrong here. And like that we receive a DOM exception because we tried to access a window object somehow, and it froze on that. So But we have in here, in the code itself, we have a fallback logic, like this JSON stringify, the native one, has just thrown. So we have like a fallback logic in place, and the problem like still happens in it, because we have seen this weird string about this the input object being too complex and stuff like that. So we just go through the webpack stuff again, and we can just step over that, and we can see that again JSON stringify is being called, so like the same thing in a way that we have just called beforehand in our wrapper. Basically in here we can jump here and inspect what has happened prior to us being brought to this stringify call here, and we again have like the object here. We have this replacer that is undefined, and we have spacer that is also undefined, and we can already see here that we have like an if-else statement, and we can recognize this funny string here, unable to serialize, circular references, too complex to analyze here in the catch clause. So like I fully expect it to be hit when I just continue here. This native call, like I don't have access to its implementation, so I can't really step into that. I can just try to do that regardless, and I'm being put here, so like expected. So if we just inspect the stack trace here, we can probably see that the result of the stringified state is being used as the value for the state for this event, and this is basically how we got to the problem. But the interesting part is like, why does it throw? And we also have like this code is in the fast save stringify module that is supposed to be handling like circular references for us, because usually we can't call JSON stringify on a circular object. So let's try var a and just assign a. That sounds about right, and identifier A cannot be declared with var in current evaluation scope. Consider trying let instead. So slightly weird, but the problem or an issue with the DevTools. So if we just change that to let, converting circular structure to JSON. And but this we have this module in place, we have this dependency to handle this issue for us. So like in the resulting JSON, we see stuff like this because this module just handles that for us, and we don't have those kind of errors from it. But we are actually, again, like we can inspect the actual error here. It's in the underscore variable, so we can see that it's again the very same thing, blocked a frame with origin, which makes sense because this JSON stringify call was basically the very same one that we have already done in a function above it. So how do we we know that we can't that the problem is about the window object. We can sort of try to find it. It's in the object variable. This one is okay. Maybe try context like this object context. No, this has null in it, so it's probably in the event somewhere. It's data. Object event data. Okay, so that's the window object. And what we can test here, somewhat like one thing, like I'm stopped in the debugger, it throws me off a little bit. I can just assign it to to, okay, so the object, yeah, to like window test, let's assign it, and let's just continue here. Okay, I might not want to being stopped here anymore. But I can just experiment with stuff here. Because like when I was paused in the debugger, I won't be able to use debugger when experimenting with this variable. So, and I actually want to do that. So yeah, like if we call just JSON stringify on this thing, we'll receive the very same error, like block the frame. Let's try this event data, the same thing, and that data is this window object. So one thing that comes to my mind is let's use a replacer and let's try to like replace it to just sidestep the logic and just prevent JSON stringify from throwing. Let's just detect that that our value is this window object, and then replace it with a custom string, because we can't really share it through another window anyway. Like it won't pass the post message boundary, like cross realm boundary. So we have to replace it anyway. So JSON stringify actually accepts this this replacer function, and this has two arguments, key and value. So let's put some additional information here. So let's just inspect how it goes through this object. We can get back to like inspecting the test object here, and let's maybe for now just return value, so it will like fall back to the native behavior without us actually replacing it with anything. So we can just invoke that. We can see the like the path in a way how it goes through that. The interesting part here that we might notice after like inspecting this is that we never get the window object as the value. And so since we can't we don't receive the value since we don't receive the window as the value here, we can't easily just replace it, which is a little bit problematic for our case, and I wonder why that is. Like we could potentially replace it at another level, because this function is recursive. It goes from the top of the object and it just descends into it one by one. So we could detect the situation like even at the root, but then we would have to scan the whole value recursively on our own and detect if it has this window object, and then like replace it with something with that custom string and just return this custom value to JSON stringify. That's problematic and it doesn't scale super well. We would really want to get like the value that window object as value here, so we could just inspect it directly and return whatever we want. So what we can do about it? Like, okay, maybe let's play around with this whole window object. So we grab this, and we can it doesn't really contain any circular references. We have kind of verified that when we were looking through the fast save stringify already kind of checked that, so it didn't detect it. Like it actually contains circular references, the window object if we just grab like our window, and if we check window self, if it's equal to window, yeah, it's true. So it actually contains circular references. So like why we didn't get any such error there and why we received another error. So this test event data object is a cross origin frame, like we kind of learned that here, block the frame with origin localhost 3000 from accessing a cross origin frame. So on such an object, we actually can't access all of the properties. So we, for example, I don't know, like let's try location. Okay, this doesn't throw, but maybe parent, this doesn't either. But if since this is the window object, we can just, I don't like focus. Okay, this doesn't throw either. So let's just use whatever, like any property, like window object. Like we can just inspect a random value on an object and or the random property, and we'll just get undefined back in JavaScript. So like principally same thing should somewhat happen here, but if this wouldn't be a cross origin frame, but it is, and we can't inspect it freely for security reasons. So yeah, but like since we can't access its properties, how like the detection logic in this fast safe stringify for circular references, how it didn't end up with this error, like how we managed to get past that logic, and how we got to the JSON stringify call itself. So like I imagine that the logic there is iterating through keys. Okay, this doesn't actually, yeah. So we have this test event data. So we see that this operation is kind of safe, and it just doesn't return any keys. Just to verify, maybe in test event data console log e. Again, we didn't get anything. This is somewhat interesting. I mean, like, so what if JSON stringify iterates over that object and tries to like stringify it? How does it throw if it doesn't kind of have anything to iterate over? So this is a little bit tricky one, because perhaps not everybody is super accused, and not everybody actually knows about it. But what JSON stringify does is that it tries to first call two JSON methods on an object. So we can sort of validate this by again grabbing this object and just trying to call it to JSON. And we get the very same error here. Block the frame with origin localhost 3000 from accessing a cross origin frame. So my like strong suspicion is that this is the root cause of the problem. Part of our problem in our application is that that our serializer doesn't control that, and like we still can't access this object as a value. And an interesting fact is that if we actually create, so we can kind of even replicate that issue with like the whole issue boils down to this. Yeah, this throws an error, and this is basically what happens with this window object. The interesting part, in a way, is that if we just do this, and we can just copy this. So let's just put an object here that has toJSON, and in here perhaps log toJSON and return this. Okay, should be working. Okay, I lost it, so let's try again. B and toJSON. Return this, and let's provide a replacer. So it's not an object, it's a function. So again, key value, and return value, but let's console log key value. So let's kind of verify how it actually works and what's the order of the operations. So we can see here that that A has been seen first. Like we got this key, we got its value, then from JSON has been called. So it is actually the first thing that happens here, and the value that is being returned from it is being then received by the replacer function. And this is basically what happens here. We get the replacer called with b key and this object with custom toJSON method on it here, and then it's being iterated, I guess. And we, like, the replacer sees the toJSON key with the value of this function, but since like this is not a JSON serializable value, it just removes it from the object, and we get some result. So yeah, basically that's the gist of the problem, or at least like why this actually happens here. The problem is like, how do we fix it? I'm not sure yet how I will go about it, because yeah, like our replacer can't even observe this value directly. So how can we fix it at our layer? We kinda can't. I don't think so. I don't see how we would. But I guess I might report an issue and start a discussion in the fast stringify repository. I don't think this is actually this one. Fast stringify, no, fast save stringify. So yeah, this is the module that we are using, and I might start a conversation with the maintainers if they are willing to do something about it, or if we need to somehow handle that in our layer, or perhaps one of the solutions here would be to potentially wrap this object somewhere in a custom one. So like this, and then then write a replacer that would actually handle this window key and replace it with this value. Because the problem is that the toJSON is being invoked. That toJSON is invoked on the window object, but we don't know the exact key to like handle it in some kind of a generic fashion, and we still won't if we even like detect this window key in our replacer. This won't scale super well because we would have to be cautious as a user to always assign this window object to such a key and so on. But I don't know, like that is at least some workaround that could unblock us there. So I hope that you have find this enjoyable, especially the toJSON bit, because it's not an obvious one, I think.